Hey there, class. Mr. Prusky here. Hope you're having a good day so far. We're continuing with Chapter 2, which is about systems. Systems are just more than one equation or an inequality. We have different ways where we can solve. And so today we're going to be talking about systems of linear inequalities, which is like less than, greater than kind of stuff. Our central question is, how do we graph systems of linear inequalities? And we have a warm-up here. So why don't you guys go ahead and graph the following. This honestly graph shouldn't be here. See if you can remember how to graph these. Go ahead for our warm-up. All right, so y equals 2x plus 5. This is graphing kind of regular equations. So what do we graph first, the 2 or the 5? The 5, we go up 5, put a point on the y-axis. 1, 2, 3, 4, 5. And our slope is 2, or 2 over 1. So we're going to go up 2, right 1, all the way across the graph. And instead of going up 2, right 1, we can go down 2, left 1. Okay. And if this is kind of still in trouble with graphing, make sure you check out previous videos or other videos on my channel here to see like how to graph equations. Okay. All right, so there's that, and so for the second one we have here, we have like this just inequality here. It's kind of a single inequality thing here, single variable inequality. So x is less than -3. We're looking for numbers that are less than -3. So is it an open or a closed circle on -3? It's going to be an open circle because, right, -3 is not less than -3, right? So this open circle means it's like not part of the solution, okay? Now, which numbers are less than -3? Are we going to go left or right? We're going to go left, okay? Because numbers to the left of -3, -5 is less than -3, right? That would work. Any numbers to the left of here are going to be part of the solution. That's why we shade that way. And so if you go the other way, right, 0 is not less than -3, so that means we're not going to shade that way because it's not part of the solution. So lines on a like linear inequality like this one up here, every like point on that line is going to be part of the solution. It's going to make it true, and every like shaded number on number 2 is going to make it true as well. And so we're going to be kind of doing a combination of these two different kinds of graphs today, which is what a linear inequality is. Okay. All right. So yeah, so let's go ahead and get into this here. Why don't you guys go ahead and see if you can fill in the blanks here. Give it a try. All right, sounds good. Okay, so it's easiest to graph these in slope-intercept form, which is y equals mx plus b. We're going to get y by itself to solve this. M equals the slope. B equals the y-intercept. We're going to graph the b first. We're going to go up or down that number on the y-axis. And we're going to use rise over run to find other points on the line. Okay? All right. And now we're adding another kind of part of graphing here. We also need to check the inequality, right? So inequalities we know we have these things, right? Less than, greater than, less than or equal to, greater than or equal to. Those are examples of inequalities, okay? So the way I like to teach this is I like to kind of do y equals mx plus b, and then I have these different like kind of rules that can help us figure out where we're going to shade and what kind of line we're going to have. Because an open circle, like up here, is basically like a dashed line for these things. It means the line is not part of the solution, okay? So for a solid line, we're going to use less than or equal to or greater than or equal to, right? Because the line is part of the solution, right? If you find like, I don't know, if you get something like, if you get something like 4 is less than or equal to 4, well, it is equal to 4, so it would be part of the solution. So it's kind of like we use a closed dot on a graph. It means it's true, so that's why we use a solid line. A dashed line is going to be not equal to, like less than or greater than. So 4 is not less than 4, so it would be not part of the solution. Okay? Below, we shade below when we use y is less than or y is less than or equal to. And we shade above, we do y is greater than or y is greater than or equal to. Okay. For left or right, this is kind of a special kind of case here. If we have a line that's like x is less than or x is less than or equal to, right? That's like kind of x equals a number. It's going to be a vertical line. So there is no above or below. And right is going to be, x is greater than or x is greater than or equal to. Okay. And if you need kind of a tip here, I want you to write this over to the left over here if you're able to. Determining above or below. Okay, the way I like to do this is I like to pick a point, and you draw an arrow straight up and down. Okay, that's it's kind of hard to tell with like a really steep line to tell which way is above or below. So if you draw like pick a point and draw straight up or straight down, it'll kind of help you tell which way we're going to shade. All right, a lot of moving parts here. Let's see if we can kind of figure this out. Okay, so let's go ahead and do number 1 here. We have y is less than 2x minus 1. So first thing I like to do is y by itself. It is. So we're going to take this inequality here. It's less than. Is that going to be a solid or a dashed line? It's going to be dashed because it's not equal to. It's only equal to if it, or solid if it's equal to. Is it above or below if it's less than? Less than we want to think below. So we're going to graph the line, and then we're going to use a dashed line and shade below. Okay. So now we're going to graph this like we normally would, as if it were y equals 2x minus 1. So if we were doing that, what would we graph first? The 2 or the negative 1? We would graph negative 1 down here, and our slope is 2 over 1, so we're going to go up 2, right 1. Okay, up 2, right 1. So I would just draw the dots here. Don't connect them yet. We can also go down to left 1 to go the opposite direction. Okay, so what we just talked about, we talked about a dashed line, right? So we're going to kind of do a dashed line. I have to eyeball here with this program. So it's a dashed line, which means it's not part of the solution. And we're going to shade below. So I'm going to pick a point here. I'm going to draw arrow straight down and straight up. So which way is below? Can you guys tell? Is it to the left or to the right? Yeah, to the right. So below would be this area right over here. And that's going to be every single point in that solution. Just going to show you an example here. Let's say we're trying to point, you don't need to write this down, but if I did like the points, let's say 2, 0, right? Where x is 2 and y is 0. Let's just test this in this equation here. So y equals 0. It's saying 0 is less than 2 times 2 is x minus 1. What's 2 times 2? That's 4. What's 4 minus 1? That is 3. Is 0 less than 3? Yeah, that's true, right? So every point that is like true is shaded, and it's in that area, right? And everything over here, if you did like 0, 0, that would be what? 0 is less than negative 1 eventually. So that would not work, which means that's why we didn't shade toward the 0, 0. Okay? All right, very cool. And that's how we do this here, all right? If you guys would like to pause and try the rest of these, that's fine. We're going to go through them in a second. All right, number 2, we got y is greater than or equal to negative 1/4 x plus 3. Is y by itself right now? It is. So we're going to go like this. Is it solid or dashed if it's equal to? It is solid. Is it above or below if it's greater than? It's above. So we're going to shade. We're going to make it a solid line, and we're going to shade above. All right. What's the first point we graph here? We go 3. We're going to go up 3 to put a point. Our slope, our rise over run, is negative 1/4. So we have a rise of negative 1. We go down 1. We go right 1, 2, 3, 4. Down 1, right 1, 2, 3, 4. Okay. You can also go up 1, left 4, right? Gotta make sure you go all the way across. It's a good idea. Okay, up 1, left 4. Make sure I got that. Looks pretty good. Okay, we're doing a solid line, so I'm just gonna make a solid line through these points. That's what I mean by solid or dash. This line was kind of dashed, right? We're shading above, so I like to pick a point here. So above would be, you can kind of see straight up, it's going to be above, so we're going to shade over here. And I would kind of get in the habit here, I don't know if you did it for the last problem, but I would not shade all the way in exactly until you exactly know where things are going to go, because we're kind of reviewing graphing inequalities here. But we're going to be doing systems where we're going to be like only shading like where they overlap, okay? So if you shade something in really hard, dark and heavy, you're not going to see where they overlap. So that's why I just kind of do the lines for now until I really see what's happening, okay? All right, this one's down here a little bit weirder. Similar thing, this is kind of Hoy Buck stuff. So we have y is less than or equal to 5. Is that a horizontal line or a vertical line? That's a horizontal line. It's y equals a number. It's going to be a horizontal line through 5. So we go up 1, 2, 3, 4, 5. There's our horizontal line. Oh, sorry, I forgot to do this here. So it's equal to, so it's going to be solid. And it's less than, so it's going to be below. So we're going to do a solid line. We're going to shade below. So we're going to shade like this. And down here is our answer. Nice. Okay, remember Hoy Vux, if you need to go back and review that. So y equals a number is going to be a horizontal line, okay? And Vux, x equals a number is going to be a vertical line, okay? Make sure you remember that. So if x is greater than -4, is it solid or dashed? It's dashed. Is it left or right? This one's going to be a vertical line. Is it left or right? Well, it's pointing to the right, so it's going to be shaded to the right. So we're going to do a vertical line through x equals -4. 1, 2, 3, 4. Oh, we're doing a dashed line, my bad. So 1, 2, 3, 4. Dashed vertical line. And we're shading to the right. So every point in that shaded section is going to be part of the solution. All right, very cool. So that's kind of a refresher of how to graph linear inequalities. But now we're going to be talking about how to graph systems of those. So kind of stepping things up a little bit here, all right? Okay, very cool. So the solutions are still where things like are shaded, but we're going to be like showing where the sections are going to overlap. Are going to what? Overlap. So it's because we're going to have multiple things happening in the same graph. The solution needs to be true for a system for all the equations or all the inequalities. And so where like those shaded sections overlap is going to be true for all of them, okay? These are all going to be solutions to the system, okay? So let's go ahead and do this here. Let's do example 1. First things first, we have y is less than or equal to x minus 2. Is y by itself here? It is. So now we can go ahead and solve, kind of like label this here. Is it solid or dashed if it's equal to? It's solid. Is it above or below if it's less than? It's below. Okay. So let's go ahead and graph that here. Let's go step by step. So we have x minus 2. How do we graph that? We go down 2, put a point. Go up 1, right 1 for our slope. That's our 1/1 is our slope from the x there. Go all the way across. Go back the other way. All right. It is a solid line, so we're just going to kind of draw a line here. Best we can. And we're gonna, it says shade below, but don't actually shade yet. Here's what I want you to do, okay? What I want you to do is just draw some arrows below here, okay? To kind of show, we're not sure where we're gonna shade yet, but this will kind of give us an idea. We can see where they overlap once we like graph the other equation, okay? Or inequality. All right, how about this one here? Got y is greater than -3x plus 2. Solid or dashed? It is dashed. Is it above or below if it's greater than? Above. So we're going to graph this. We're going to go up 2, put a point. Down 3, right 1 is our slope. Down 3, right 1. And also up 3, left 1. And so it's a dashed line. So we make a dashed line here. All right, and it's shaded above. So I'm just going to draw some arrows going straight up from a bunch of points here to see where they overlap. Can you guys see where these are going to overlap? What do you guys think? That's not what I want. What the heck was that? I don't know what's going on here. So where do these overlap here? Can you guys see? So we need to be below the blue line and above the green line. Hopefully you can see below the red, blue line and above the green line is going to be this section right over here. Okay, so it's kind of the right section like this. All right, that's above the green line, below the blue line. Okay, so that's kind of how we do these here. Yeah, you're seeing where they overlap. Why don't you guys go ahead and try number 2, 3, and 4 if you're able to. Otherwise, we'll go through them in a second. All right, number 2, we have y is by itself, which is good. It is it's less than, so it's not equal to. It's dashed and below. Dash and below. So we're gonna graph this. We go up 3, put a point. We go down 1, right 2 for the slope. Up 1, left 2. And we do a dashed line. Best we can. And we're going to shade below. So we're going to draw some little arrows going down. All right, so we're not sure where they're going to overlap yet, but we'll do the best we can here. This one over here, it's not equal to, so it's dashed. And it's above. So we go up 1, put a point. Up 1, right 2. Up 1, right 2. All the way across, down 1, left 2. And dashed again, so we go dashed. And so for this one, we're going above the green line. So we're gonna go above here. So can you guys see where these are gonna overlap? So they're gonna overlap on the left-hand side, below the blue line and above the green line, like that. This section right here is where they're gonna overlap. Nice, very cool. All right, if you want to try 3 and 4, see how you do. You have some weird examples in here. You got y equals and x equals. See if you remember how to do those. Okay, we have y is greater than or equal to. This one's going to be solid. It's equal to and above. So if we graph that, we go up 2, put a point. Our slope is down 3, right 2, down 3, right 2, down 3, right 2, down 3, right 2, and up 3, left 2. And it's a solid line, so we make a solid line. And we're shading above, so I'm going to draw some little arrows above. Kind of give us an idea where stuff's going to go eventually, hopefully. All right, we have this one down here it is dashed, it's not equal to, and it is above. So is y equals, is that a horizontal or a vertical line? It's a horizontal line through -1. So we go, oops, that's not going to work. So -1's like this, horizontal line, we're shading, oh sorry, it's a dashed line, whoops, got to fix that. So a dashed line through -1. And we're shading above, so drawing some arrows above here. You see where they're going to overlap here? So it's got to be above the blue line, above the green line is going to be somewhere in this section over here. All the way down. Okay. All right. Very cool. Last one over here for this part. We got y is less than or equal to x plus 3. That's solid or dashed. It is solid. Is it above or below? If it's less than, below. So we go up 3, put a point. Up 1, right 1 for our slope. Down 1, left 1. All the way across. It's a solid line. It's not a great line. It's still not great, but it'll work. We're going below, so draw some arrows below. Okay, and then this one right here is going to be a solid line, and it's shaded to the right because it's a vertical line. We do a vertical line through -1, so here's -1. We're shading to the right. Let's draw some arrows to the right. So which section are we going to shade here? It's going to be this section down here. It's going to be below the blue line and to the right of the green line. It's going to be that section. Okay. All right. Now we got a couple left here. We got to challenge ourselves. So for these, like number 6 is going to be graphing multiple things, like an extra inequality. Number 5, we have to make sure we get y by itself here. If you'd like to try these on your own first, that'd be great. Otherwise, we'll go through them in a second. All right. I forgot to mention up here too, like to draw the arrows thing, like we talked about. Okay. So for this one, it's y by itself for this top one here. It is not, so we need to get y by itself. So we have x. Oh, one more thing I forgot to mention here, okay? This is kind of a thing with inequalities, okay? Remember, if you multiply or divide by a negative number, you must flip the inequality. Okay, so be careful with that. If we multiply or divide when we're like kind of solving stuff, we have to flip the inequality. So we have x minus y is greater than or equal to -2, I believe. Okay. So you gotta solve for y here. How do we solve for y first? We're gonna subtract x, get y by itself, and now we have -y is greater than or equal to -x minus 2. Keep it in y equals mx plus b form. Now, how do we get rid of this negative in front of the y? We're gonna divide by -1 to change the sign. But now we divide by negative, so what we got to do to this? Got to flip it to less than or equal to. And it's going to be negative x divided by negative 1 is positive x. Negative 2 divided by negative 1 is positive 2. So that's our new equation. Now we can graph that. So we have x plus 2. We're going to go up 2, put a point. Go up 1, right 1, all the way across. Down 1, left 1. And it's going to be, I guess we should have done this too, it's a solid line. And it's going to be below. That's really bad. Solid and below. So we're going to make a solid line. We're going to shade below, just draw some arrows for now. Okay. All right, other one over here, we have 4x plus y is greater than negative 3. Gotta get y by itself. How do we do that? Subtract 4x. Get y is greater than what? Negative 4x minus 3. Do we need to flip it or no? We do not, because we did not multiply or divide by a negative. This is going to be a dashed line and above. So we go, let's see, down 3, put a point. We go down 4, right 1. Could also go up 4, left 1. Up 4, left 1. And it's going to be a dashed line. Let's see here. And we're shading above. This is kind of hard to see. It's pretty steep. So just draw arrows straight up and down here. So where are they going to overlap over here? Can you see that? Yeah, it's going to be this right-hand section over here. Okay, I can kind of shade that, make it easier to see. All right, and that's our solution for that one. Try number 6 if you're able to. This one's going to be kind of where they all overlap. See if you can do this one. All right, y is less than or equal to 2. So this is going to be, it's a solid line. It's below. So we go horizontal line through 2. So now I'll make it a little bit like that. Okay. We're shading below, draw some little arrows below here, see what's happening. All right, next one we have is we have x is greater than or equal to negative 1. That is going to be a solid line again. It's shaded to the right because it's a vertical line. So now we do a vertical line through negative 1. Vertical line through negative 1. We are shading to the right, draw some little arrows to the right. Okay, so now we're in the bottom right of this these two graphs here. Then we have this one here. This is going to be solid and above. Okay. So we're going to go down 3, put a point. We're going to go up 1, right 2, all the way across. Down 1, left 2. It's going to be a solid line. And we're shading above. So you can kind of see, if we zoom in here, it's going to be this little section right in here. So if we do this, this is kind of the shaded section where they overlap. Okay? So it's the intersection of all 3 of those graphs is going to be that little triangle right there. All right, and that's all I have for you today. Thank you for watching. Have a great day, and we will talk soon.